First we will study what is simple gear train. In simple gear train, a single gear is mounted on one shaft. This type of gear train is called as a simple gear train. On one shaft, one gear is mounted. This type of gear train is called as a simple gear train. Now, in that animation, we are observing that in first animation, we are observing that A and B gear both are separate gears mounted on two different shafts. Now, first is rotating clockwise, B gear is rotating in anti-clockwise direction, in opposite direction of first gear. The first A gear, we will assume it as a driver, and second gear, B gear, we will assume it as a driven gear. Whereas in second animation, we will observe that A gear, first gear is driver gear, and second gear, B, is driven gear. In both animations, A is driver and B is driven gear, but we are observing that the diameter of these both gear is different one, isn't it? Now let us assume that A gear is a first gear, which is a driver gear, and B gear is a second gear, which is a driven gear. Therefore, the speed ratio between these two gears can be represented as, or can be given as, N1 upon N2, or it is the ratio of speed of driver gear to the speed of driven gear, isn't it? And it is also equals to the inverse of their number of teeth, that is T2 upon T1. This ratio is speed ratio. For simple gear train, speed ratio is equal to ratio of speed of driver divided by speed of driven gear, isn't it? Now it may be noted that this ratio of speed of driven or follower to the speed of driver is known as a train value. That means reciprocal of speed ratio is a train value, that is N2 upon N1, it is equal to T1 upon T2 is the train value. Remember this for a simple gear train. Now this simple gear train we are observing in many applications. In lathe we can see, or in some various different application we can observe this simple gear train in which a single gear is mounted on a single shaft. Now sometimes the distance between the two gears is very large, or distance between two shaft, input shaft and output shaft, is too much large. The motion from one gear to another gear in such a case may be transmitted by two ways, either of two ways. First way we can use by providing the large size gears. That means suppose in that figure A is the driver gear, C is the driven gear. If suppose I have to transmit power from A to C, I can use first method as the two gears can be made A and C such a large diameter that both will mesh to each other. But this has disadvantage that two larger sized gears are used, which may consume larger area. But because of that, we can use the second method, that is by providing one or more intermediate gears, and these intermediate gears are called as a idler gear. Now let us discuss regarding that idler gear. A little consideration will show that the second method, that is using idler gear, is more convenient and economical. Now it may be noted that when the number of intermediate gears are odd, the motion of both the gears, that is driver and driven, is same. Consider an example as shown in this diagram. A gear and C gear are input and output gears. In between that I have used odd number gears, that is suppose I have used only one gear. Therefore driver gear will rotate in suppose in anti-clockwise direction, therefore idler gear will rotate in its opposite direction, that is clockwise direction. Therefore to B gear, C gear is in mesh, therefore C gear will rotate in opposite direction of idler gear, that is again in anti-clockwise direction. Therefore input and output shafts are rotating in the same direction because of one idler gear. If such a 3 idler gear you will provide, then also input and output shaft will rotate in same direction. If 5 number of idler gears you are using or intermediate gear you are using, then also you will get the same direction of rotation of input and output shaft. But if you are using even number of intermediate gears, then the motion of driver and driven gear will be in opposite direction. Consider a case in between A and this C gear I am using 2 intermediate gears. In that case A is rotating suppose anti-clockwise, first intermediate gear will rotate in clockwise, second intermediate gear will rotate in anti-clockwise, and C gear will rotate in clockwise direction. Therefore both the gears will rotate in opposite direction, input and output gears, in case of even number of idler gears, isn't it? Now for this gear train, simple gear train having A, B, C gears or 1, 2, 3 gears, we will find out what is the velocity ratio or speed ratio. What is velocity ratio? We have seen earlier as well, that is velocity of driver divided by velocity of driven, that is N1 upon N2 for first 2 gears. Suppose A gear is first gear, B gear is second gear, therefore for these 2 gears velocity ratio will be N1 upon N2. It is equal to T2 upon T1, reciprocal of tooth number of teeth. For second meshed gears, second and third, we will again apply velocity ratio. It will be N2 upon N3 is equal to T3 divided by T2. This will be the velocity ratio for second and third gear. Therefore combinedly multiplying this first equation and second equation, we will get velocity ratio for this total gear train having 1, 2, 3 gears. It will be N1 upon N2 into N2 upon N3 is equal to, in terms of teeth, T2 upon T1 into T3 upon T2. Therefore N2 will get cancelled, T2 will get cancelled, and remaining will be N1 upon N3 is equal to T3 upon T1. That is speed of first gear divided by speed of last gear is equal to number of teeth of last gear divided by number of teeth of first gear, that is N1 upon N3 is equal to T3 upon T1. Same thing I can write, speed ratio is equal to speed of first driver divided by speed of last driven is equal to number of teeth on driven gear divided by number of teeth on driver gear, isn't it? And reciprocal of this speed ratio will be train value. You can identify this train value as a reciprocal of speed ratio. This is regarding idler gear. Now this idler gear is used for 2 functions generally. First function is to connect the gears where a large center distance is required. Suppose A and C gears are not too much close, they are having large distance, then this gap can be bridged by these idler gears, a number of idler gears. Second function of this idler gear is to obtain the desired direction of motion of the driven gear, isn't it? That means A gear, suppose driver gear and driven gear you want in the same direction, you can use odd number of gears. If suppose you want opposite direction for input and output gear, you can use even number of gears in between driven and driver gear, isn't it? That is regarding idler gear. Second type of gear train we will see is compound gear train. Now observe that animation. In that you are observing that gear A is mesh with gear B. Gear B again is mounted on one shaft. On same shaft, gear C is mounted. Gear C is in mesh with gear D. Now from this first animation, black colored animation, you will observe that A is mesh with B, B and C are mounted on same shaft, C is in mesh with D. This type of gear train is called as compound gear train. That means when there is more than one gear on one shaft, such kind of gear train is called as a compound gear train, isn't it? Now, whenever the distance between driver and driven or follower has to be bridged over by intermediate gears, at the same time a great speed ratio is required, then the advantage of intermediate gear is intensified by providing compound gears, isn't it, on this intermediate shaft. I will repeat this sentence once again. Whenever the distance between the driver and driven, that is gear A and gear D, has to be bridged by intermediate gears, as well as if we want to increase a large amount of speed ratio, we require large amount of speed ratio also, then the advantage of intermediate gear is intensified by providing compound gears, isn't it? In this case also, each intermediate shaft has two gears rigidly fixed to each other so that they will rotate in the same direction. You can observe in that animation once again, gear A is meshed with B, B and C are mounted on the same shaft, and you can observe B and C gears are rotating in the same direction, that is anti-clockwise direction, isn't it? Now, if you want to find out the velocity ratio for this compound gear train, first find out velocity ratio between gear A and B. Velocity ratio is found between the two gears which are in the mesh. A gear is in mesh with B, therefore A gear I will call as a first gear, B gear I will call as second gear, C as third and D as fourth. Therefore velocity ratio between 1 and 2 or A and B is equal to N1 upon N2 is equal to T2 upon T1. Between 3 and 4, that is C and D, velocity ratio is N3 upon N4 is equal to T4 upon T3. And for gear and velocity ratio between 5 and 6 in this diagram will be N5 upon N6 is equal to T6 upon T5. This I have considered a different gear train than that animation. 6 gears are connected to each other, and this 2 and 3 are compound gear, 4 and 5 are also compound gear, transmitting power from first gear to sixth gear. That is, first gear is driver gear, sixth gear is driven gear, and intermediate gears are compound gears. 2 and 3 mounted on same shaft, 4 and 5 gear are mounted on same shaft. This gear train will also be a compound gear train. Therefore, this will be velocity ratios between each meshing gear. Then the total velocity ratio for this gear train can be found by multiplying these velocity ratios as N1 upon N2 into N3 upon N4 into N5 upon N6 is equal to, in terms of teeth, you can write. Now cancel out the velocities for gear 2 and 3 because these are mounted on same shaft. These will have the same velocity. N2 and N3 will get cancelled. 4 and 5 gears are mounted on the same shaft, therefore N4 and 5 velocities will also be get cancelled. Therefore remaining velocities will be N1 upon N6. Understand why? Because N4 velocity is equal to N5, N2 velocity is equal to N3 because these are mounted on the same shaft, will have the same velocities. N1 upon Nc is equal to now N1 upon N6 is equal to now remaining T2 into T4 into T6 divided by T1 into T3 into T5. This will be the velocity ratio for this gear train. Now this is regarding compound gear train. Now you can put the values of number of teeth and find out the value of velocity ratio. If number of teeths are not given, velocity is given for these gears, and asked to find out velocity ratio, you can find out velocity ratio by dividing N1 divided by N6. This is compound gear train.